Well, hello and welcome. It is time once again to try to fix something, and today on the workbench we have a PS5 Digital Edition. Now this was sent in by one of the viewers of my channel. His name is Eric, and I agreed to take a look at it. It's a no power. I think it's also a no beep. And I think he mentioned that he had taken it somewhere and they told him it was a power supply, and he tried a power supply and that didn't fix it. But so I didn't know it was going to be in pieces, Eric. You didn't mention that. So, yeah, I'm not going to try to turn it on now because I see like the Wi-Fi antennas are sticking out down there. You can see them. So, yeah. So we're going to take a look at this and see if we can do anything with it, but it obviously has been worked on before. But yeah, let me get down to the circuit board and see what it looks like, shall we? Alright, well, we are down to the main board here. All the screws are out of it, of course, in the bag. But I wanted to see this board to make sure there was nothing, shorting. Nothing horrendous looking before I apply any power to it, but I don't see anything. So apparently just the supply has been changed out, and that had no effect. Okay, now that I've seen it, let me see if we can get some power into this. I need to move these covers. They're just going to be in the way. Put them on I have a table behind me. Let's see. Let's see if we're getting any. I guess I could try to turn it on. Nope. Okay. Confirm. Dead. No beep. Oh, let's find a good ground. Do we have 5 volts? This is an EDM10 board, so this is going to be the original version of the PS5's board. Now, where's the 5 volts? Trying to remember. No, don't tell me. Let's just confirm we have 12 volts, shall we? Yeah, 12. Supply is good. Let's see, what about right up here? Oh, that's ground. I can't remember if that's 5 volts or not. What's right here? I don't think this is 5, but it's one of the standbys, like a 3.3 or something. There's nothing there. Cannot remember where all these rails are. What's over here? I mean, so far all I've seen is 12 volts. Nothing there. Nothing there. Oh, those capacitors are for the USB ports, I believe. That's for the SSD, which won't be there right now. All right, there's 12 volts at that location. That's going into like the supply generator for the RAM, which is not really our concern right now. These rails only come up when it's running, I believe. I believe that's like a 5.25 and a 3.3. I'm thinking this is 5 volts up here, and it is dead. So yeah, your old Southbridge isn't going to do a whole lot up here. I'm looking on some of these coils around the Southbridge. I mean, there's just nothing happening. But we have 12 volts coming in. So do we have a blown fuse somewhere? Let's get it inside to the workbench and find out. Right, I'm taking the main board out. What happened to the clock backup battery? What happened to the liquid metal? It's everywhere except where it should be. Okay, let's get this inside. Alright, we are inside of the workbench. I apologize for the flicker on the meter screen, but it's my new toy and I want to use it, so yeah. Let's see if we can get some power into this board. EDM 10. Make sure we get our polarity right. Let's see. Okay, I'm going to give it 12 volts and just see how much current it draws. Turn that off. And let me adjust this current down. I've got it set where I could, try to power a full board, not just standby mode. Okay, if I turn it on, she draws no current. Well, it shows 2 milliamps, which is probably just noise. Let me unhook this. No, it's drawing. It said my power supply says 1 milliamp there. It says 2 milliamps there. Something is very, very dead. Quite dead on this board. Now I can see that coil. I know that's the 5 volts right there. We're not getting 5 volts. Okay, that's step one of a working PS5 board. So, okay, we're getting 12 volts into the coil here. So the output fuse is, that's not really the issue because we're not getting any output. So we're getting 12 volts to this circuit. So this is the coil for it. This is a couple of MOSFETs. There's some filter caps. I wonder if we have a short there. Let me turn off this. Do we have a short on our 5 volt rail? Is it that simple? I like simple. After the ones I've been dealing with bad RAM, I'll take simple any day. Oh yeah, we have a dead short on our 5 volts, which is probably one of these little ceramic caps right over here. Which, I mean, I've seen other people on YouTube have those. I don't think I've ever had one of those, which I was surprised because apparently they were common, common issue. So yeah, we have a short on our 5 volt rail. Well, that's nice. I like that. So I can stop injecting power. Let me get set up then. Is there anything on the other side of this board? Nope, there's nothing else there. So all the components for this 5 volt circuit are right here. The IC, there's a choke here, input filter, output filter. Okay, let me try to get set up, see if we can inject some voltage, and maybe we can see what's getting hot, shall we? Let me get set up for that. I have to switch to the thermal camera and get some wires into there. Give me a second. All right, I looked at that wrong. Our short is not on those capacitors. Now that I look under the microscope here, I was checking over here, which is ground. So this is on the 12 volt rail coming in. So, and there's definitely no short there. I had 12 volts on this coil. So our short is not on the input to this, it's on the output. It's on the output side. It's on the 5 volts itself, not the power coming in. So yeah, and I'm seeing liquid metal. Look right there. See it on top of that capacitor. I'm not sure if that's going to be an issue or not. Probably should have looked around this board. But yeah, our short is on the 5 volts itself, but we can inject 5 volts. Yeah, let's see how low. Let me zero out my meter. How much of a short do we have? About 0.15, 0.14 ohms is what I forgot. So that's pretty good little short. So how about we just solder a wire right here, you know, beyond the fuse, so I can't blow my fuse, right there, and I'll inject 1 volt that I can easily increase to 5 volts if needed to get enough heat. But yeah, let me just see if we can do that. Where is my solder? Oh well. Oh, here's some. Okay, now where is my wire? I had some little short pieces of wire. Yeah, here it is. Cut just for this kind of thing. And they get moved around on the workbench. Come on, stick. Should probably go across both those pads. Yeah. There we are. All right, that should be a pretty good connection. I guess the thing, let me switch back to the thermal cam and we'll inject. All right, I think we're set up and ready. Let me turn on the supply. Oh yeah, we're drawing full 3.2 amps. Ooh. What is that? Right there? Looks to be one of the USB power switches or a capacitor on it. Kind of hard to tell. Yep, pretty warm. Okay. That's odd. Maybe there's a shorted capacitor in there. But anyway, it's one of these ICs that switches 5 volts out the rear USB ports. Okay. All right, I think I found the offending component. Let me show you under the microscope here. You can get a better view of it. There's that IC. You know, it's a switch that switches the 5 volts, and it's also like a current sensing type device. But if I turn on I'm injecting 1 volt still. Look at this capacitor right here beside it. Yep, that's our problem. Shorted capacitor right there. Okay, so let's see if we can remove that. My syringe is squirting out flux everywhere, so I thought I would pick that up. Get my nozzle back on. Let's see if we can remove this bad boy. I'm set at 420. I'm going to have to raise it up. These boards just really soak up the heat. I mean, it's hooked to a large ground plane. And it just says no. Okay. Let me do what I should have done in the beginning. And that is add a little bit of leaded solder. to either end of it. And I'll bump this on up to 440 or so. Come on, let go. Finally. Okay. Let's just check. Do we have a short any longer? We do not. We do not. Okay. I think that's going to be. Let me pull one of those. I don't know what the value. That's a pretty large capacitor. It's probably like a 10 microfarad or something. Let me find a donor board nearby. It's another EDM10. And we will just take that same capacitor. See if I can ease this out of the way a second. How about that? Yes, that's too much flux, but it just keeps coming out of the syringe. I'm sure you know what I mean. They like to just spew. Again, I'm adding some leaded solder. It's not low melt, it's just regular old leaded solder. Just trying to lower that melting point there. Make life a little bit easier for us. Kind of surprised this, didn't blow the fuse. Okay. Let me set my donor out of the way. Let me get that in the shot. Maybe we'll try to get a value on this thing just for the heck of it. For future reference. It's a little warm right now, so it may be a little, reading may be a little off. Oops, where'd it go? Come on back. Nope. The end caps are kind of rounded with the solder right now. It makes it kind of difficult. Stay there. 22 microfarad. 22. Okay. Grab our little donor. And find the focus. Okay. Just adding a little bit of leaded solder there to ease this thing back down. Need to get a hold of it good so it doesn't go flying. I know it wants to. It wants to take off. That'll work. Now we'll get rid of some of that solder. Beautiful. At least as good as factory. At least as good as factory. I didn't go too crazy with the flux. Okay. Let me disconnect my voltage injection wire over here. Maybe clean that off a little. Okay, let me get you set back up and we'll hook 12 volts to this thing and just see how the current draw looks. Alright, well, we are set back up, ready to hook 12 volts into this board and see if it gives us a normal initialization. Make sure I got my polarity right. I do. I have it right there at the power supply. Okay. There you go. Look at there, 320 milliamps or so. Come back down. This baby will work. Assuming we do something about that. I've got to clean that up and get some fresh thermal liquid metal on there. But so let me do that, and we'll be ready to test this. All right, we are back outside in the garage. I'm getting ready to reassemble this for testing, and I've cleaned up the top of the APU there. Gotten rid of the liquid metal that was splashed around. And there were a few places on the board of splashed liquid metal. Not a whole lot, just a little here and there, and I cleaned those up. Cleaned up the surface of the heat sink there. We're going to try to get some fresh, brand new Thermal Grizzly liquid metal in there. And also I replaced the battery, the clock backup battery, because that one was missing. And then when I was blowing out the chassis, blowing out the heatsink fans, down inside there, I found the original battery rolling around inside. So, okay, I'm glad I found that before we send it on its way. Let's see if we can get a little bit of liquid metal on here. I have not had to replace this stuff very often. I mean, usually there's plenty, you know, laying around on the die to distribute. But in this case, it had all like went off to the side. Maybe I could have drawn it up and reused it, but I knew I had this out here in the garage, bought some time ago. So I figure what the heck, we'll just put some fresh stuff on here. Okay, and maybe a little up here. What do you say? Just a little. I don't go crazy with this stuff. I mean, I just get a good coating on there and call it a day. But yeah, they do like to oxidize and create bare spots. Well, that's not looking too bad. Let me clean up the mess I made a little there. Stuff is hard to catch. Okay. Alrighty. Alright, let me get this put back together and we'll test it out. Alright, I've got her back together enough to test. Let's just see if she'll turn on. That looks promising. Yep, I saw the monitor lock. I thought I did. I think it did. Yeah. There it goes. All right, now we're repairing our storage. I guess we're going to reboot. Yeah, the capacitor's on the other side of the board from that, so we couldn't see it from here. So alright, that looks good. Let me get it fully reassembled and we'll bring it up entirely. How's that sound? Alright, well, she is back together. The bag of PS5 screws is now empty. So I don't think I was missing any, so that's good. But yeah, she went back together fine. She is working fine. So Eric, you are in luck. This is your lucky day. Just one little cheap 10-cent capacitor took down your very expensive PS5. Well, I hope you everyone out there enjoyed this one. Thought it was somewhat interesting, educational, or fun, or whatever. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.